Pleasant morning to each and everyone. We are here to present our thesis study entitled Design and Fabrication of a Modified Rotary Quartz Sand Sieving Machine, with the members of Kim Addison R. Doreen, yours truly, Francis Nieves, Kenneth C. Hineta, and John Ray Kalinga. Background of our study: sand is a popular constituent in concrete and construction, with a variety of possibilities based on the project's requirements. Over human timescale, sand is a non-renewable resource, and sand suitable for concrete production is in great demand. Each year, 50 billion tons of bleached sand and fossil sand are used in construction. The EMO, Global Environment Management Office, reports that Engineer Renato Delaver, the head of the Environment Management Office, also named at least 45 active quarry permits in about 30 of the 47 towns. Sands are getting increasingly scarce over the time. This is a significant difficulty for the construction sector. The majority of structures are composed of concrete, which contains 60% sand. Because sand is a natural product, its properties can vary significantly, necessitating the use of a sand sieving machine. Relevant rules apply to sand used in concrete manufacturing. They normally have a grain size of 0 to 2 mm, whereas gravel and shippings have a grain size of 2 to 8 mm. One of the most important areas of science and technology today is automatic control. This is due to the fact that automation is intertwined with the advancement of almost every type of technology. We come up with an idea to save construction and quarry workers' time and energy by designing and fabricating a modified rotary sand sieving machine that employs electricity and a solar power backup to meet the beneficial qualities of the sand, and a sensor to automatically fuse sand to the detected container. Statement of the problem: the previous study's researchers created the sand gravel segregator that segregates particles from the unwanted ones. That was driven by an electric motor used as primary. They use a cylindrical drum-cooled trommel screen, which consists of a series of screens with different sizes of holes. The cylindrical drum is made to rotate to segregate the gravel from the fine particles of the sand. This machine has some drawbacks. They have been recommended to improve the structures of their machine for better performance by putting a mechanism that shall drive the feed aggregates to exit properly to their respective outlet, and to improve their machine by adding other parts for better functionality. Objectives of the study: the following will be the researchers' primary focus in this study. First is its design and fabricate a modified rotary quartz sand sieving machine that sieves, separates, and filters sand from a mixture by an AC single-phase capacitor, start motor with a solar backup power, and with a sensor that automatically fills sand container upon detection. Second, it has the functionality of a modified rotary sand sieving machine and its performance in terms of efficiency, production rate, and power consumption. To compare the machine design produced in the current study with the previous study of Lubrigas et al. In terms of machine design, speed of work, and product output. Significance of the study is for the construction workers, community, quarrymen servers, masseurs, researchers of the future, and beneficiaries. Conceptual framework: the sand sieving machine. Next is mixed sand input, down to the sieving mixed sand. Next is the separate sand and dry, and lastly is the sand container. Scope and limitations: the goal of this research is to design and fabricate a modified rotary sand sieving machine that filters sand automatically. The studies also look at the machine's efficiency and compare it to the efficiency of human labor. The researchers use advanced SolidWorks software to design the machine, and the materials used in the machine fabrication are solely those available in the book of Mark. The locale of the study will be in Dangal, 30 people, with a latitude of 9.64 north, longitude of 123.98 east, and an altitude of 285.4.
And now for the chapter 2, which is the review of related literature. First, we had the introduction. The second, properties of sand. The third, emergence of sand sieving machine. For the last part is types of sand sieving machine, which falls into 4 categories. First, traditional sieving machine. Second, rotary sand sieving machine. And the third, vibratory sand sieving machine. And for the last one is the sand screening cum washing machine.
Chapter 3, Methodology, Introduction. Sieving is a physical mechanism of particle removal, where a particle is denied access through a pore or passageway that is smaller than the particle itself. The fine mesh strainer, also known as the sieve, is a device of separating wanted elements from unwanted material, or for characterizing the particle size distribution of a sample. Typically using a woven screen, such as a mesh or net or metal, this chapter will present method to achieve the researcher's purpose of designing and fabricating a machine that will improve the efficiency and quality of filtering the sand. It discusses the instruments and materials to be used and the process flow of making the machine. It also tackles on the procedures of fabrication and assembly of machine, as well as on determining the machine's efficiency and quality. The process flow in making the machine is study of sieving machine. Second is the selecting the project's components and materials, reputation, fabrication, and assessment, analyzing the result. The working principle is the working principle of the sieving machine mainly depends on converting rotary motion provided by electric motor, the current in battery, and converting from the solar energy of electrical energy. Rotary motion produced by electric motor is transmitted to shaft fitted with sieve net using belt drive. Shaft is fitted to framework with the help of bearing. The homogeneous mixture of sand and pebbles are fed from a slider which falls on the sieve net fixed on the rotating shaft. Then due to relative motion between particles and rotating sieve, the particles smaller are passed through the net and remaining particles falls on the other side. The fine sand will not directly fall into the ground. It will be stored in a hopper for the automatic filling. To actuate the servo to open the outlet of fine sand, whenever the sensor observes a low distance reading due to an obstruction in its line of sight. When a container comes below the fine and outlet and obstructs the sensor line of sight, the Arduino board receives a low distance reading and instructs the servo motor to actuate and open the outlet. Conceptual design is the parts of the machine. First is the hopper, second is solar panel, third is frame, fourth is rotary mesh, fifth is automatic filling, the Arduino ultrasonic sensor and servo motor, and sixth is electric motor, belt, battery, and seventh is wheel. Component used in sand filter: motor, frame, pulley, bearing, belt, battery, solar panel, adapter, power supply controller, mesh frame, Arduino Uno, ultrasonic sensor, servo motor, and the selection of materials is ferritic stainless steel, low carbon steel, galvanized iron, GI sheet, bolts and nuts, switch, and the other equipment is the welding machine.
Analyzing the result. The researchers will test the functionality of the modified quart sand saving machine and its performance in terms of efficiency, production rate. The production rate of the machine is recorded and plotted in the table shown below. Power consumption. In measuring the electric consumption of machine, the test composed of 3 trials. Each trial has a span of 15 minutes in equal amount of samples. The total amount of samples per trial is 10 kg dry quartz sand. The table presents the electric consumption of modified rotary quartz sand saving machine. Speed of work. Comparison of performance level in terms of speed work between the sand gravel segregator and the modified sand saving machine. The researcher will provide the amount of sand in mid-3 trials. Product output. Presents the comparison of performance level in terms of product output between the sand gravel segregator and the modified quartz sand saving machine. Computation for the difference between sand gravel segregator and modified quartz sand saving machine. Thank you.